Objective versus imperative versus functional. Imperative meant that everything you wrote was sequential, and you would write statements in order that they were to be executed at runtime. The computer would read your code just as you would read an essay. So that was imperative programming. So imperative programming means computer will read this code sequentially except for a go to statement. So like reading, this is like reading an essay. The only exception was when you used the command go to, which would send the interpreter backwards or forwards to specified line number in code. So this go to statement will redirect us in a specific line in code for doing that task again and again. This was very straightforward to understand, but it also became impossible to manage as programs began to reach millions of lines, which happened a lot. Then procedural programming came along, which solved some of the issues by containing sections of code in discrete sections called procedures or subroutines. So there were procedures and subroutines. This meant that certain instructions could be called on over and over again and edited separately from main code, but seeing as you had to call the procedures, the code would still be taking a long winding journey and making countless stops along the way. This is what is referred to as a spaghetti code. Classes and object explained. In OOP, subroutines are replaced with classes, which in turn are used to describe objects. An object is a collection of data with properties with behaviors called methods. Our collection, our collect coin script, which is really a class called collection, describes the behavior of coin to disappear when collected. So coin is getting disappeared when it is collected. To increase the player coin's value and the properties, the position of coin, its size and so on. The class acts like a blueprint and can create as many coins that as object as it want, just as blueprints for a house can be used to create a lot of houses. So this one single blueprint of these coins can be used for creating a lot of objects, just like a blueprint of one house can be used for creating many houses. Similarly, blueprint of this that is coin object, it can be used for creating many coins. We call those instances of objects. When we destroy our coins, we are destroying instances for those coins rather than class itself. A class need not to be attached to a sprite at all either. So class is not needed to be attached to a sprite. A class can also be used just for crunching numbers and manipulating other classes. You could write a script that is class to control the time limit. For instance, and the object in this case would be the time limit, an abstract concept rather than something you could move around, but it is still an object and it's still defined by the class. So object is defined by class. This is also what happens when we tell Unity that we are using certain classes at start of each script. These are classes provided by Unity that provide additional functionality and that we can access these methods and properties of. When we write those lines, we are telling Unity that we want to access some methods and properties that it has created for us.